Good morning, everyone. I would like to thank the students from Animal Science 3A for having me as your speaker. I hope you're all doing well, and I wish you're all ready for my topic today about the different types of poultry housing system for tropical climate. So let's start. Poultry physiology. The desirable body temperature for chickens are 105 degrees Fahrenheit to 107 degrees Fahrenheit. Comfort zone is 18 to 22 degrees Celsius. The chickens are less tolerant of heat than cold because of its feathered body. High-yielding exotic breeds have temperate origin. Tropical environmental effect, more high-yielding birds. Mas susceptible and sensitive ang high-yielding birds when it comes to climate. Slight changes in climate like the increase or decrease in the temperature may have a big effect in the health of chickens. Strong effect of environmental factors and poultry house design should be directly related to environmental conditions. Importance of housing. First is comfort and protection. Scientific management in a controlled manner, easy, convenient, and economic operations. Reduces the total cost of production, maximizes flock performance, ensuring better health and welfare, proper microclimatic conditions, increased stocking density, and optimum and uniform growth rate. Showing the illustration are the three type of poultry housing systems. First is the free range or extensive, the semi-intensive, and the intensive. Under the intensive are slat cam litter, slatted floor, deep litter, and cage. Under the cage are stair step or California, battery or vertical, and lastly is the individual. Free range system. All this system and adapted only when adequate land is available. Rearing of poultry by letting them loose on ground or field called as range. A range should provide shelter, greens, feed, water, shade, and etc. Foraging is a major source of feeding for birds. Shelter is usually provided by temporary roofing supported by ordinary poles. Stocking density is 300 to 400 birds per hectare. At present, almost outdated. Semi-intensive system. Commonly used by small-scale producers. Birds are halfway reared in houses and halfway on ground or range. Birds are confined to houses in night as per the need. They are also given access to runs. Houses may be simple house, thatch roof, littered earth floor, or slattered. Provides protection from inclement weather predators and shade. Stocking density is 4 to 5 birds meter per square in houses. Fold unit system. Shown the illustration are the two types of the fold unit system. House and run combined, part of which is covered with chicken wire and the remainder with solid walls. A unit 6 meters by 1.5 meters for 6 to 18 birds. Floor space is 200 square meters per bird. Moved each day over an area of grassland similar to the deep litter system but requires more space. A considerable amount of litter for the yard and the flush green floor for the birds. More expensive and less durable. Deep litter system. Poultry birds are kept in large pens on floor, mainly for broilers. Floor is covered with litters such as straw, sawdust, or leaves up to depth of 2 to 3 inches. Bird density is 5 to 7 birds per square meter. Easy access for feed, water, egg, collection, and provide good protection. The disadvantage is that it requires high quality litter and litter-borne diseases. Slattered or wire floor system. Small houses with a slattered or wire mesh floor. Slats, wooden pieces of 2.5 to 5 cm wide placed at 2.5 cm apart, running through the length of house. Slats placed 3 feet above the ground floor to allow accumulation of dropping. Bird density can be 6 to 8 per square meter. Feeding, watering, and egg collection handled from outside the house. Cooler houses but expensive and suitable for adult bird only. Combination of slatted floor in deep litter. 60% slatted area and 40% litter area. Slats on either side of house against each side of wall leaving central portion of litter floor. The area is raised above the concrete floor by 0.5 meters or more to accumulate manure below the slatted area. Waterers and feeders are placed on the slatted area. Bird density is up to 5 to 7 per square meter. Expensive and complicated management. Aviaries. Multi-tiered buildings for cage-free housing. Several levels of flooring, use of vertical space, perches, and platforms. Allows birds to jump to different levels. High density of birds up to 25 birds per square meter. Cage system. Rearing of poultry on raised wire, netting floor on smaller compartment called cages. Initially introduced for individual egg and pedigree recording and culling of 4 layers. At present, 75% of commercial layers in the world are kept in cages, suitable for keeping high density of birds when space is limited. Scientific managemental practices can be followed. Feeders and waterers are attached to cages from outside, except nipple waterers for which pipeline is installed through or above cages. Auto-prepared feeding trolleys and egg collection belts can also be used. The droppings are either collected in trays underneath cages or belts or on floor or depth pit under the cages. The recommended floor space is for chicks 0 to 8 weeks equals 0.3 square foot. For growers 9 to 16 weeks 0.5 square foot, and for layers above 17 weeks is 0.6 square foot. The shown in the illustration is the structure of cage. As you can see, we have the waterer, the food trough, and the egg tray for the faster collection of eggs by the layers. The floor slope is 1.5 inch per running 12 inch. Types of cages. Based on the bird density. If you have only one bird in a cage, then it is called single or individual bird cage. If you have 2 to 10 birds, it is called multiple bird cage. And if you have more than 11 birds per cage, it is called colony cages. Based on the number of rows. Single deck, the double deck, triple deck, and the four deck. Based on the arrangement of cages. Battery cages or vertical cages. We have stair-step cages, and under stair-step cages we have M-type cages and the L-type cages. Based on the type of bird reared, we have the brooder or the chick cages, the grower cages, layer cages, and the breeder cages. As you can see in this illustration are a different type of cages, the individual, the colony, and the battery cages. California housing, high-rise or elevated cage house. This type of houses provides sufficient ventilation and wage management in tropical countries. The height of the shed is raised by 7 to 8 feet from ground level using concrete pillars. The distance between two pillars is 10 feet. 2 feet wide concrete platforms are made over the pillars. For 3 M-type cages, arranged 4 platforms are needed. The inter-platform distance is 5 to 8 feet depending upon the type of cages used. The total height of the house is 20 to 25 feet and the total width is 30 to 33 feet. You can see in the illustration the different types of housing and the respective measurements. Modern housing system. In recent years, most poultry operation are intensive type houses with environmental control house, in which inside conditions are maintained as near as to the bird's optimum requirement. The temperature needed is 24 degrees Celsius. The relative humidity is minus 50 to 60%. A closed building with no windows. Longitudinal preferably east to west with big exhaust fans on west side while evaporative cooling pads on east side, along with automatic feeding and drinking systems inside. Fully system controlled with no manual controls. Feeding system, watering system, manure collection system, and egg collection system are all mechanized and automatic. Environmental Control House, or ECH, helps to achieve better FCR or feed conversion ratio, improving production, care of birds, control diseases, and meet other safe breeding conditions. One extra batch or cycle per year per shed. You can see in the illustration the different types of environmentally controlled houses. We have the different types of principles of housing, the selection of site, housing design, housing environment, housing equipment, housing space, light, housing hygiene and sanitation, and lastly, the biosecurity. First, selection of site. It must be located away from residential and industrial area. Soil and drainage, basic amenities like water and electricity must be considered. Shade and protection, relation to other building, proper ventilation, availability of farm laborers at relatively cheaper wages, market, and proper road facilities. Housing design. Distance between sheds. Preferably locate chicks, growers, and layers in different localities for better biosecurity. House orientation or direction. If you have hot and cold climate, the orientation of the housing is northwest to southeast, so that the portion of the housing that is exposed to sunlight is balanced. If you have cold climate, the orientation of the housing is north to south, so that a bigger portion of the housing is facing the east where the sun rises. And if you have hot climate, the orientation of the housing is from east to west, so that the small portion of the housing will be facing the east where the sun rises. Foundation, solid and concrete. Concrete blocks and bricks with 1 to 1.5 feet below the surface and 1 to 1.5 feet above the ground level. Length can be of any extent. Width, not more than 30 feet. If the width of the shed is more than 30 feet, ridge ventilation at the middle line of the rooftop with proper overhang is must. Can be of any width in EC houses or environmental control houses up to 40 feet. Height. Height of the sides from foundation to the roof line should be 8 to 10 feet, eaves height, and at the center 10 to 12 feet. In case of cage houses, the height is decided by the type of cage arrangement, 8th year or 4th year. Side walls. Protect the bird from adverse climate and provide sufficient ventilation. Usually half to two-thirds area will be kept and open and fitted with wire mesh in floor houses. In cage houses, avoid side wall. Environmental control houses should have solid side walls. Types of roofs. Draft and moisture proof. Sufficient overhang. Insulation values of R4 and R2 for ceiling and walls, respectively in hot climate. Painted with a reflecting type of paint such as aluminum paint or polyurethane insulation under the roof or above the ceiling. Drop ceilings. Modern houses are well insulated with blown in cellulose or glass fiber batt. Protect the trusses and ceiling insulation by acting as a vapor barrier. Reduce the ceiling surface area and reduce heat gain during hot weather and heat loss during cold weather. As you can see in the illustration, the three types of roof. First is the shed type. As you can see, the roof is slanted on one side only. In the two-thirds span roof, the slant, the two slants of the roof is unequal. In the gable roof, the two slants on the roof is equal. Shown in the illustration are the two types of housing style. First is the monitor style, and the second is the half monitor style. This is it. Types of roofing material: the aluminum sheet roofing, the asbestos sheets, asphaltic roofing material, thatch roof, roof whitewashed, spray polyurethane insulation, and the rigid board insulation. Types of floors: concrete floors, with rot-proof device and free from dampness, extended 1 to 0.5 feet outside the wall on all sides to prevent rot and snake problems. Consists of well-drained soil or gravel or concrete, which is more desirable. It is easy to clean, durable, and more rat-proof. A concrete floor should be 80 to 100 millimeters thick and be made of a stiff 1:2:4 or 1:3:5 mix, laid on a firm base at least 150 millimeters above the ground level, and given a smooth finish with a steel trowel. Doors. The doors must be open outside, mostly in deep litter poultry houses. The size of door is preferably 6 by 5, 6 by 2.5 feet. At the entry, a foot bath should be constructed to fill with a disinfectant. Different types of floor. First is the kacha floor or the natural floor which has no litter. Second is the concrete floor. Third is the plastic slatted floor. And the fourth is the wire mesh floor. Housing environment. Macro environment are factors that cannot be manipulated. Local environment around the animals are composed of temperature, gases, humidity, dust and microorganisms, and particulate matter. Also, microenvironment around the animals are composed of air quality, relative humidity, and temperature. Control over microenvironment can be achieved by: first, by completely eliminating macroenvironment contact with the house. Second, by completely enclosed from outside inclement weather conditions. And lastly, hence environment inside the house is in our control. Here, the concept of environmentally controlled has arisen. Ventilation or air movement. Moving fresh air into a house and moving stale air out of the house. Sending unwanted heat, excess moisture, ammonia out of the house. Limiting the buildup of harmful gases and providing oxygen for respiration. Natural ventilation. Natural outside air can easily flow into and out of the house. The ventilated shelter must be exposed to the wind. Wind breaks reduce natural air movement, keep them 100 feet away. Increased air exchange rates by installing fans. Proper building design and construction major factors which affect ventilation. Mechanical or forced ventilation systems. All air movement is produced by fans and controlled by automatic environmental control mechanisms in the building. Positive pressure systems use fans to blow fresh air into the building, creating a slightly higher pressure inside the house. Pressure difference moves the stale air to escape through strategically placed exhaust vent or outlets. Negative pressure ventilation. Exhaust fans expel air from the building, creates a partial vacuum inside that pulls air into the house, evenly through all inlets, creating more uniform conditions in the house. Inlets are distributed around the periphery of the building. Having a tightly sealed house is critical for successful control of in-house conditions and negative pressure ventilation. Tunnel ventilation. Most effective in tropical climate due to higher air exchange rate and faster air movement at 2.5 to 3 meters per second. Fresh air entered the house at one end and pulled through the house in longitudinal direction by means of high-performance fans. Cross ventilation. Fans on one side of the house, inlets on the other side. Works best in houses of less than 10 meters wide. Sidewall ventilation. Fans and inlets on the same side walls. Attic inlet ventilation. Fans are distributed at the side walls, inlets are in the roof. Cross ventilation. Fans on one side of the house and inlets on the other side. Works best in houses of less than 10 meters wide. Sidewall ventilation. Fans and inlets on the same sidewalls. Attic inlet ventilation. Fans are distributed at the sidewalls. Inlets are in the roof. Components of mechanical ventilation systems. Fans and openings. Control the amount of air exchange. Effect air distribution and mixing. Heaters. Provide supplemental heat during cold weather and brooding. Controls. To adjust ventilating rates, fan controls. Supplemental heating rates, and the air velocity rate or fan controls. Supplemental heating rates and the air velocity through openings as weather, bird age, and size change. Fans. Placed on the windward direction of the houses. Install low-speed industrial fans 1 meter above the ground. Use 1 by 620 millimeters RPM fan per 1,000 layers. And environmental controlled houses, important to determine how much airflow through the building, which determine the number of fans required. Airflow rate equals cross-sectional area of the house times required speed desired. A minimum of 1 M2 inlet area per 14 cubic meters per hour. Exhaust fan capacity is recommended. Openings. Air inlets to provide fresh air throughout the building, control direction of airflow, and maintain sufficient inlet air velocity. Inlets for negative pressure ventilation systems. Continuous slats and discrete box or area inlets. Continuous slats inlets have a rigid movable baffle for controlling the size of the opening. Bottom hinge baffles are preferred. Continuous inlets may be positioned along both edges. Tunnel ventilation requires a separate set of inlets. Unplanned inlets includes large openings such as doors, windows, and fans without shutters, which are not originally designed to be part of the ventilation system. For best airflow and mixing sidewall inlets should open 5 to 7.5 centimeters. Too small openings do not allow adequate airflow or throw. Too wide opening directs air downward, gives no added airflow. Ceiling inlets should open at least 2.5 centimeter in the clear for proper airflow pattern in mixing. 2 centimeter board opening, 2 centimeters throat opening. Fully open air inlet allows airflow but reduces air velocity and throw. Pipes, wires, or ducts and ceiling break up airflow and direct air downward. Heaters. Supplemental heat is needed in natural and powered ventilated houses to maintain desired indoor temperatures during cold weather and brooding. Different types of heaters are used for supplemental heating in poultry houses, including radiant space and make-up air heaters. The different types of heaters are the radiant brooder, the pancake brooder, the forced air furnace, and the radiant tube heater. Automatic controls. To maintain the indoor temperature and provide air exchange as weather changes hourly and seasonally. Regulate the supplemental heating. Solid-state controllers and computer systems capable of controlling the inlet and outlet opening and supplemental heaters. So, for the automatic controls, it controls indoor temperature. Mostly the poultry houses that has this kind of controls are in Western countries because it is cold in the places. So they needed it the most. In the Philippines, some use it, but mostly we don't need it. Others use it just for ventilation purposes only. Insulation. A well-insulated building is needed for environmentally controlled houses. It prevents condensation on the inside surfaces, reduces heat loss in cold weather, and reduces solar heat gain in warm weather. Evaporative cooling. Under the evaporative cooling is the sprinkling systems, fogging systems, and pod systems. Sprinkling systems is used for very dry climates. Fogging systems is used for naturally ventilated housing and power ventilated housing, while pod systems used for power ventilated houses. Foggers. Under the fogger system are the low pressure fogging and high pressure fogging. For the low pressure fogging, inject fine water particles, low cost fogging system, high quality and durable PVC pipes are used. The high pressure fogging, micro mist fog size is 10 to 15 micro. Fogger in true sense discharges fog, not water. Operated intermittently or designed to avoid excessive water. High pressure and durable stainless steel pipes are used. So the difference between the two systems is that high pressure fogging is around 65% more effective than low pressure fogging, but it is more expensive. Evaporative cooling pads operate on the same cooling principle as foggers. Cold air enters the house. When it passes through the wet pads above, which water runs throughout perforated pipes. This method avoids the problem of wet litter. Concrete coated baggage pad, aspen fiber, rubberized hog's hair pad, and corrugated cellulose or cardboard or fluted cardboard pads. Materials widely used as cooling pads. Feeding. Automatic feeders have one loop of feeder chain and capable of feeding a given number of birds. A feeding control system to turn the feeders on and off. Feed monitoring systems are available to measure the amount of feed consumed by bird. It is important that same amount of feed to be available at all locations along the feeder. To show in the illustration are the different type of feeders. First is the tube feeder. The tube feeder holds up to 15 kilograms or 30 pounds of chicken feed, with its high sides, lip, and segment bars, it feed it keeps feed loss to become less. The side deepness can also be adjusted to suit from top screw. Second is the hanging type feeder. It can also be called as a circular feeder. 30% more birds can be accommodated in a hanging feeder when compared to linear feeder. Third is the linear through feeders. The linear through feeders is available in different sizes, usually made of galvanized iron. However, it can be made out of locally available materials like wood and bamboo and etc. Round bottom and square bottom feeders. The round and square bottom feeders mostly used in cage birds. The automatic feeder, it dispenses the feeds automatically. Watering. Shown in the illustration are the three types of drinkers. First is the fountain drinkers, second is the automatic drinkers, and the third is the nipple drinkers. Medication system allows for medicines to be administered through the water lines. Egg collection conveyor belt system. The egg conveyor belt is very flexible, making the system suitable for even in the smallest process. Lighting. Environmentally controlled houses should be light-proof. Use of light trap at openings. A monitoring and control system for scheduling of lights. A system that can pre-program lighting schedules over the life of the flock is very useful for management. It is also important to provide the desired intensity of light. Lighting is provided by incandescent lights with dimmer switches. There are three types of lighting. First is the incandescent lights, the fluorescent tube lights, and the compact fluorescent light. Lighting is also important because more luminescence the place, the encouraging it is for the chicken to eat, and the higher the production rate. Waste management. The byproducts of poultry production are of value if managed and recycled properly, regardless of flock size. However, if not managed or recycled properly, they also represent elements, compounds, vectors for insect and vermin, and pathogenic microorganisms which are of concern. Biosecurity. Biosecurity refers to procedures used to prevent the introduction and spread of disease-causing organisms in poultry flocks. Because of the concentration in size and location of poultry flocks in current commercial production, operations and the inherent disease risks associated with this type of production, it is imperative poultry producers practice daily biosecurity measures. Conclusion. Automation is the need of our to reduce labor costs and increase poultry production. California houses with automation is better option in tropical climate. Thought should be given to environmental control houses while constructing houses in hot climate if capital is available. Civil engineers or architects should be involved while planning and designing poultry houses. So this is the end of my presentation. Thank you for watching and listening. I hope that you have learned something. Thank you and see you again next time.